Hello everyone, this is Shankar. Now I want to explain about uninformed search algorithms. Let me start with the definition of uninformed search algorithms. Actually, uninformed search is a class of general purpose search algorithm which operates in brute force way. Uninformed search algorithms do not have additional information about state or the search space other than how to traverse the tree. So it is also called blind search. Generally, uninformed search algorithms, there will be a simple algorithms to search any state. There is no requirements, any additional information about the state. So here generally uninformed search algorithms are 6 types. They are breadth first search, depth first search, depth limited search, iterative depending depth first search, uniform cost search, bidirectional search. So we start with the breadth first search algorithm. The definition of breadth first search: breadth first search is an algorithm for traversing or search tree or graph data structures. It starts the tree root and explores all the neighbor roots at present depth prior. It moves in nodes at the next depth level. There will be in depth first search algorithm, it will search the nodes one by one level. So the main advantages of breadth first search: BFS will provide a solution if any solution exists. So it will provide a solution if any solution exists. The main disadvantage of breadth first search is it will take more time. So the time complexity, space complexities are there. So let me discuss with example. This is a tree. In breadth first search, there will be A will be called as parent node or the main node. So here A will have the 2 child nodes. So we start with main node A, and here our goal node is J. So we start with searching A. So current state is A. Here when we are coming to A, here 2 directions are there, B and C. So first in breadth first search, it will first it will go to left node, then it will go to B. So B state will be there, current state, and C will be remaining. And here after B state, there will be 2 waiting states are there, D and C. So first of all, I am told you what is that breadth first search is a level by level state. So first it will go B and then it will go to C. So C state will be confirmed, and then after C there will be 3 states are there, 3 nodes, D, E, F. It will be go in waiting state. Then there is no goal node, so it will go to D, and then D, E, F. After D confirmation, it will go to E. The same procedure will be go until the J state will be come to in current state. So it will go E and F and G, H. So after H, it will go to I, and then after I, it will compulsory go to J. So our goal state will be J. So goal state is there. This is the breadth first search algorithm. So the direction in breadth first search goal is from A first, and then it will go to B. After B, it will go to C, and then C to D, D to E, and E to F, and after F, it will go to G and H and I. So our goal state is J. When we are coming to J, it will the goal state. So the searching is completed. I think all of you understand breadth first search algorithm. yeah, after breadth first search algorithm there will be depth first search algorithm. So depth first search is a recursive algorithm for traversing a tree or graph data structure. It is called the depth first search because of it starts from root node and follows each path to great depth node before moving the next path. So the main advantage of depth first search is it will take less time, and the disadvantage is there there is the possibility that many takes keep recurring. So there will be the more states will be repeating. So this is the main disadvantage of depth first search algorithm, and the time complexity is O of n power m, and space complexity is O of b m. So where m is the maximum depth of any node. So let we explain with example. So depth first search algorithm, there will also it is a tree. The main a tree, a node will be called as the root node. So in current state it will start with a, and then b will be arrived. After b it first search the leftmost tree. It will give the priority for the left node only. So after completion of left node, then and only it will go to right. So after d it will go to g, and then it will come to back to d, and then it will go to h. So the same procedure will be occur until the completion, and then it will start with e, c also. So it will give the step by step procedure until our goal node will be searched. So here j will become, so j is our goal node. So the path is, so the path of searching in depth first search is from a to b, b to d, d to g, and then it will go back d to h, c, e, then I, and it will come back to e, and then j. J is our goal state. So this is the depth first search. I think all of you understand about depth first search. The third algorithm is uniform cost search algorithm. Uniform cost search is a searching algorithm used to traversing a weighted tree or graph. This algorithm comes into play when a different cost is available for each tree. Generally, in uniform cost algorithm, there will be, it will depend on the weight of the path in a tree or graph. So the advantage of uniform cost search algorithm is uniform cost search is optimal because of it every state path with the least cost is chosen. So there will be chosen a least cost path. The main disadvantage of this algorithm is it does not care about the number of steps involved searching, and only concern about the path cost. So it will depend on only path cost. The time complexity is c star by epsilon plus 1, and space complexity is O of b power 1 plus c star by epsilon. So let we discuss with one example. Here our goal node is g. So in uniform cost search algorithm, there will be, it will depend on the cost. So in the current state is s, and then there will be two child nodes for s. So here a will have one weighted, and g will have 12. So weighting order is a and g. So here a have less cost, and then it will go to a. After that a have c, b, g states, and then here list have C, and then it will go to C. After C, here D and G are the child nodes of C. D have 1 and G have 2, so it will go to D. So after that, after D it will go to G. So here our goal node is G, so it will stop here. So our path is first it will start from S to A, and then after A it will go to C, and then it will go to G, D, and then it will go to G. So it will calculate the cost, and then if it is its cost is very high, then it will go to back, and then it will go to search for another G. So I think all of you understand about uniform cost search goal, uniform cost search algorithm. So another algorithm is depth limited search algorithm. Depth limited search algorithm is similar to depth first search algorithm. There will be a small correction is there. In depth limited search can solve the drawbacks of the infinite path in depth first search. The main advantage of depth limited search is memory efficient, and then disadvantage is it may not be optimal if the problem has more than one solution. Time complexity and space complexity are there, and we discuss with a small example. Here the depth limited search algorithm, there will it will start from last depth, I mean last level. There will be a last level is 3 and our goal node is J. So here from root node it will start to searching, and after A it will go to B, it will go to D, and then G. After G it will come back to, it's similar to depth first search, so it's very easy to understand. See the path, and then it will go to G. So here left tree there is no our goal state, then it will go to right tree. So after searching our goal node will be there J, so it will stop here, and the goal state is there. So here we discuss the path from A to B, and then B to D, and then G, and then it will come back, and then H. After H it will go to right tree E, I, and then it will come back. After E our goal node is J, so it will confirm. And take another example, depth limited search level 2, our goal node is J. So same procedure will be there, A and then B and then D and then G. So same procedure will be there. Here G will not come there because of we search for depth only 2, I mean from level 2, so it will stop for level 2 only, and then it will searching start. So here our goal node is not there, so it will stop there, and depth is small. So I think all of you understand the depth limited search. So we will go to iterative depending depth first search. So So it is a combination of DFS and BFS algorithms. Uh, this search algorithm finds out the best depth limited and does it by gradually increase the limited until a goal is found. So the main advantage is combines the benefits of BFS and DFS search algorithms. Um, the main advantage is here. What are the benefits are there in BFS and DFS? It will combines, and disadvantage, time complexity. So we discuss with example. So iterative depending search from depth 0. Our goal node is J. So start with A, and there is no goal node. So it will be step by step procedure. Then we go to depth, first depth, and then after A it will go to B, and B2 it will go to C. So here also we don't have our goal node, so it will go to second depth, and then start the searching. So it's like a buffering. Uh, if it is there in goal node, uh, our goal node if is there in level, so it will stop to search, and same in depth 3 our J will be there. So our goal node is there. So it is a iterative depending search. So it will be step by step procedure, uh, like BFS and DFS. So I think all of you understand about iterative depending search, and we go to bidirectional search algorithm. Bidirectional search algorithm runs two simultaneous search. There will be two paths. Uh, when a tree is there, there will divided into two paths, and then it will start from two sides. So advantages of bidirectional search algorithms: bidirectional search is fast, and it requires less memory. And disadvantage, implementation of bidirectional search is difficult. So the implementation is very difficult. Time complexity and space complexity are there. And let we discuss with a small example. Here the tree is there, divided with ninth node. So the in bidirectional algorithm, there will searching will starts from root node and then goal node also. I think you understand bidirectional search. Uh, these are all about uninformed search algorithms. Thank you everyone. Thank you. Bye.